Righto, general math students, let's have a look at this problem from the examples in the textbook. So we're told here that we have mixed problems involving cosine and sine rules. So when we start to get into these larger examples, or these larger types of problems, the trick really is being able to tell, well, what am I going to use here? Sine rule or cosine rule? Can I use Pythagoras theorem? Can I use just sine, cos or tan from the regular right-angled triangle trigonometry? So we'll start this example and we'll explain which rule we're going to use and why. So we're asked in this one to find the closest distance that the factory is from the road. So we've got a factory here and this road's going up this way. So that means we want to find this length along here. Rather than height, I'll call it D for distance. Now this is going to involve a couple of calculations. What we could do is find this side first, or we could find this side first, and it doesn't really matter what we decide to do there, but for the purpose of this video I'll calculate this side length here. But if you did do the other one, and you could still complete the problem by finding that first and then finishing off from there. Okay, so let's see. We haven't got enough information yet to find that side length. I'll just call it X for now. We're going to need some more information. So one thing we could do is start to work out some more angles in this triangle that we have here. So by calculation we can tell that this here must be the difference between 180 and 68. Alright, we can tell what that is, which gives us 112 degrees. And while we're at it, let's subtract these two angles inside this triangle from 180 to find that one up there, just in case we need it. So that gives us 44 degrees up here. So we can see here we've got two side lengths involved, one that we want to find and one that we've got, and at least two angles. Now remember, two side lengths, two sides, two angles leads us to the sine rule. So we're going to use the sine rule to get this value for X. Okay, so you might want to pause the video at this stage and see if you can write down the equation that would for the sine rule that would work to get X in this situation. Okay, I'll have a go at it now. This is what we should get. X over sine 24 equals 2 over sine 44. So just rearranging for X. And if we put that into the calculator, we should get 1.17 kilometers, rounding to 2 decimal places. Okay, so we'll go from there. Now we're going to find this distance D, and we have a right angle triangle in this case, a right triangle here. So we've got we've now got the hypotenuse of this right angle triangle. Okay, it is 1.17 kilometers. All right, now we're trying to find the opposite side. So that means we're going to use sine. So it's not the sine rule, it's just regular sine from our right angled trigonometry. Sine of 68 equals D, the opposite, over the hypotenuse, 1.17. So D equals 1.17 times sine 68, which would give us 1.08 kilometers. Or we could say 1.1 kilometers if we went to 1 decimal place. So these types of problems are usually going to involve at least 2 calculations, and in this case I suppose there were more calculations because we needed to do some angles as well. So in addition to the angle calculations, working out the side lengths, a couple of calculations involved each time. Okay, go ahead and look at the description for the video and try those questions.